Assalamualaikum and a very nice day to Dr. Azia. For this subject, BEKP 2453 on assignment 1, we need to do video presentation based on the selected topic. We from group 5 choose surface charge to explain about this topic. So, for our video contain to 3 parts, which is for part A, intro or surface charge, for part B, formula or surface charge, and then for part C, example solution or surface charge.
Hi, Assalamualaikum and salam sejahtera. My name is Nur Amira Syafiqah binti Aman Shah, B0119100207. I am the first presenter for the introduction part.
My name is Nurul Nazirah binti Nursan, B0119101116.
Hai, nama saya Nurul Ain binti Salimun, B0119101990.
Assalamualaikum warahmatullahi wabarakatuh. Me as a fourth presenter, my name is Nur Syara Sofia binti Muhammad Zainuddin. My metric number B0119109192.
Hi, Assalamualaikum to all lecturer Dr. Azia binti Kamis and to all my fellow friends. My name is Khairul Imran bin Imam and my matrix number is B0119100242.
Okay, hi. So first and foremost, we want to start our presentation with the introduction to the surface charge. Okay, so for the introduction to the surface charge, so here I want to explain 3 terms about this surface charge. So firstly is about charge density. So as according to the electromagnetism, charge density is defined as a measure of electric charge per unit volume of the space, either in 1, 2 or 3 dimensions. And to be specific, the linear surface or volume charge density is the amount of electric charge per unit surface area or volume respectively. So the second term is the surface charge. It describes the electric potential difference between the inner and outer surface of different states like solid and liquid, liquid and gas and liquid. So the third term is the surface charge density that is only present only in the conducting surfaces, and it describes the whole amount of charge Q per unit area A.
I will explain about the formula for surface charge density. Surface charge density is the measure of how much electric charge is accumulated over a surface. Surface charge density is calculated as the charge per unit area. If Q is the charge and A is the area of the surface, then the surface charge density is given by the unit of charge is coulomb C and the unit for area is meter square. So that the SI unit of surface charge density is coulomb over meter square.
Okay, now we will go to the example 1. A conducting spherical shell with radius 2 cm and 3 cm carries a net charge of 5.3 microcoulomb. So here the biggest one, spheres have net charge of 5.3 microcoulomb and have a radius 2 cm and 3 cm. A conducting sphere with radius 1.2 cm and carrying a net charging of 2.8 microcoulomb is at the center of the shell. So here the center of spheres and have a net charging of 2.8 microcoulomb and have 1.2 cm. So the question is to find the surface charge density on the inner surface of the shell. So the answer you need must be in column per meter square.
So hi, I will continue to explain the solution of example 1 that we need to find the surface charge density. So this one, the formula of surface charge, which is sigma equal to negative q over 4 pi r square, which is q is the column, and then we know that the radius in the inner surface we have 2 cm that we need to convert to meter. So I divide by 100 and I got 0.02 meter. So we just need to put in the formula. So for the column, we have 2.8 micro, and then we divide by 4 pi multiplied by the radius, which is radius 0.02 meter. So we just put in the calculator. So we multiply 0.02 meter squared with 4 pi and then 2.8 micro. We just divide the answer. So we got the answer, which is negative 557.04 microcoulomb per meter square. So next, we need to find the net charge on the outer surface of the sphere. So Q1 plus Q2 equal to 5.3 microcoulomb. So we know that we have the Q2, which is Q1 equal to 5.3 microcoulomb minus by Q2, and then what the Q2? So 5.3 microcoulomb minus by negative 2.8 microcoulomb. So we got the answer, which is 8.1 microcoulomb. Next, we need to find the net charge per unit area on the other surface of the sphere. So this one as usual, sigma equal to coulomb over 4 pi r squared, which is the formula. And then we know that for the outer surface, we had a radius equal to 3 cm, and then I convert to meter. So I divided by 100, and then I got 0.03 meter. And then we just put the value in the formula. So the column we already calculate. So we got 8.1 microcoulomb. And then we need to divide it with 4 pi, and then for radius 0.03 meter squared. So I already calculate with calculator. So I got 716.197 microcoulomb per meter square.
So the question is, calculate the surface charge density of the sphere whose charge is 12 C and the radius is 9 cm. So we list out all the information given. So the charge equals to Q is 12 C and the radius is 9 cm, while the area for sphere and the formula is 4 pi r squared, and the sigma is charge divided by radius. You will get the charge. Okay, so let's calculate. We have to calculate the area of sphere first. The radius, you have to convert it from cm to meter. So 9 cm equals to, you will get 0.09. You will get 0.09 square. And then the answer for the area of sphere is 0.1017 meter square. Okay, next is we have to calculate the sigma. The formula for sigma is this. So the charge is given 12 divided by the area is 0.1017, and then you will get 117.994. Therefore, the final answer is sigma equals to 117.994. this is the final answer.